We'll continue the descriptive epidemiology from here onwards. Let me share the screen. Descriptive epidemiology, this is the overview of descriptive epidemiology. In this, first we will see an introduction to descriptive epidemiology. Later, we'll see what are the questions asked by descriptive epidemiology, like asking questions, making comparisons. Then we will see the procedures or steps involved in descriptive epidemiology. Step by step, what are the procedures in sequence. Descriptive epidemiological studies are usually the first phase of an epidemiological investigation. The studies are concerned with observing the distribution of disease or health-related characters in human populations and identifying the characters with which the disease in question seem to be associated. These are the first phase in an epidemiological investigation. Any epidemiological investigation, any epidemic investigation, whatever may be, first we will begin with description of the things. Here we will see the distribution of the disease or the health-related states, and we identify the characteristics or the factors which seems to be associated with the disease. But we will not test the things in here. Just we identify these are the things which are present, but we didn't establish any type of association. Just we will see the things which are identified or seeing the things which are associated with the disease outcome or health-related process. Such studies basically ask questions. What are those questions? When is the disease occurring? Means the time distribution. Where is it is occurring? That is place distribution. Who is getting the disease? Who are the persons who are getting the disease? That is person distribution. The various procedures involved in descriptive studies may be outlined as below, or the steps which are involved. First starts with defining the population to be studied. Next, defining the disease under the study. Next, describing the disease by time, place, person. And then followed by measurement of the disease with several indices having a numerator or a denominator or a frequency like that. Comparison with known indices, already known. With that indices, we will compare it. Later it ends with the formulation of an etiological hypothesis. First, defining the population. Define the population based in terms of total number, its composition by age, sex, occupation, cultural characteristics, similar information needed for the study. We are defining the population, total number of population, or something you are doing a study on adults and girls, the age group of the girls. You are doing on women, the sex matters. In suppose menstrual hygiene, in ladies only will do menstrual hygiene. The occupation, we are seeing stress among the doctors, the occupation of the doctors. The cultural factors that are involved in different communities. Like defined population can be whole population in geographical area or specially selected group. As I already mentioned, some age, sex, occupation, hospital patients, school children, visual acuity, one of the studies which are commonly done for the school children during the field visits. Defining the disease under the study, that is operational definition. Clinician may not need a precise definition for the immediate care of the patient, but the epidemiologist, whose aim concern is to obtain accurate estimate of the disease in a population, needs a definition that is both precise and valid to enable him to identify those who have the disease from those who do not have the disease. Means epidemiologist should have a which is precise, valid, doesn't change, and it is applicable and it is applicable throughout the study. He can't change just by saying that there is tonsillitis. As clinicians say, there is inflammation. He starts some medications. It is over for him. His job is over. But the epidemiologist should develop a criteria and follow it, and until it is a type of definition like that. In this, the epidemiologists see this tonsillitis in the presence of enlarged red tonsils with white exudate, with which on throat swab culture grow predominantly Streptococcus pyogenesis. All should be there. There should be Streptococcus pyogenesis, enlarged tonsils, red tonsils, white exudate. All present, then only epidemiologists conclude it is a tonsillitis, but a clinician doesn't need such an elaborate operational definition. Describing the disease. The primary objective of descriptive epidemiology is to describe the occurrence and distribution of health-related states or events, characteristics within the population. So he is describing the disease by time, place, person, and also he is identifying the characteristics associated with the presence and absence of the disease in individuals. Already in introduction, we talked more about this, describing the disease. Describing the disease, it may be by time, place, person, as already told. It may be the time, maybe year, season, month, week, day, or hours of onset or duration. The place may be the climatic zone, country, urban area, or rural area. It may be local community, it may be towns, it may be cities, it may be some institution. The persons may be different age group, the sex, the marital status, married, different occupations, different social status, the education, the birth order of the person, the family size, more the tuberculosis may spread because of overcrowding. Take example of tuberculosis, the height of the person, the weight of the person that determines BMI. You can see case of obesity, the high blood pressure, blood cholesterol, personal habits, all talks about the person, like the time, place, person. Time distribution. The pattern of disease may be described by the time of its occurrence, maybe by week, maybe by month, maybe by the year, the day of the week, hour of onset, etc. Epidemiologists have identified three kinds of time trends or fluctuation in occurrence of the disease. Based on the time, how it occurs, how it changes, the pattern. On that they describe the time occurrence of the disease. Short-term fluctuations within a short period, like epidemics, periodic fluctuations, some period of time they will take. Long-term or secular term, many years it takes to describe a long-term or secular trend. First, you will see short-term fluctuation in the term, mainly the short-term, best-known short-term fluctuation is the epidemics. Epidemic is defined as the occurrence in community region of cases of an illness or health-related states clearly in excess of normal expectancy. We expect some this many number of cases should be there, but it is more than that. Then then it called is an epidemic. Means excess of that cases or the health-related states. Epidemicity is usually relatively usual frequency of disease in the same area among the specified population at the same season of the year. Same you have to take, same year, same population, same time, like that. There are different types among these short-term fluctuations. Based on some sorts or how the epidemic proceeds. It may be common source epidemic. It may be single exposure or point source. It may be continuous or multiple exposure. Propagated epidemic, person to person or through food vector borne. It may be animal reservoir transmitting the disease. Slow epidemics or modern epidemics. We'll see in this in the next slides. First of all, what is an epidemic curve? A graph of time distribution of epidemic cases is called epidemic curve. In this, you can see in this figure, there is time on the x-axis, number of cases on the y-axis. As the person is exposed to the disease processes, as time goes, the number of cases increased, and then the number of cases decrease. So like that, we can see the epidemic curve, which is a graph of time distribution of epidemic cases, is called epidemic curve. Time distribution. According to time, how the cases are occurring in a specified population, in a community at a specific period of time. So it is a graph of time distribution. Epidemic curve is a graph of time distribution of epidemic cases. Common source epidemics. In this common source, first is the single exposure epidemic, also known as point source epidemic. The exposure to disease agent is brief and essentially simultaneous. The resulting cases all develop in one incubation period. Suppose you take example of a hostel children who are got food poisoning. All at one time, all develop the disease at one time, and then all the cases occur at a one time. Single exposure, one time exposure. Common source, food poisoning, same food, common source, same poisoning, single exposure. All have eaten on the same day. The main features of point source epidemic: the epidemic curve rises and falls rapidly, and no secondary waves. Rises and falls only one time, so no secondary waves will be there. Epidemic tends to be explosive. There is clustering of cases within narrow interval of time. If it is all the cases, there will be clustering, and all cases will develop in one incubation period. Mostly due to infectious agent, these point source epidemic, most of the point source epidemic are infectious due to the infectious agents. Example I have already given, that is food poisoning. They may be result of contamination by the industries, like you can see the Bhopal gas tragedy. Minamata disease in Japan resulting from consumption of fish contaminated with methyl mercury. That is emanated from an industry where the fish is contaminated because of eating that. They got a disease that is called Minamata disease, where there is a neurological disorder. Common source, continuous or repeated exposure. Epidemic continues over more than one incubation period. The exposure from the same source may be prolonged, continuous, repeated, or intermediately, not necessarily at the same time or place. Sometimes epidemic starts as a common source, continues as a propagated epidemic, like example is cholera. Here he is telling there is continuous repeated exposure. Suppose you take example of a well. It is contaminated with some type of hepatitis A or cholera, something. Okay. So the people repeatedly exposed to the contaminated water, drinking daily the same water, some more people will be infected. Continuously, repeatedly, they are exposed to the same source of infection. Sometimes it gets propagated also. Example of hepatitis A, polio. It goes, the agent carries to another place and gets transmitted to other people. Sexually transmitted diseases also common. So a commercial sex worker having some type of sexually transmitted diseases, several clients will be affected. Repeatedly, several clients approaching to her will be infected, and they may also infect to others. Okay, like that, it is a common source, continuous exposure. It may be a repeated exposure. It may be get propagated to others also. A prostitute may be a common source in a gonorrhea outbreak, since she will be infected with her clients over a period of time. There is no explosion. You raise in number of cases, a well-contaminated, nationally distributed brand of vaccines. Propagated epidemic. Mostly the infectious origin may be get propagated. It may be person to person. Epidemics of hepatitis A or polio gets propagated. I already told sexually transmitted disease is also a propagated epidemic. Through arthropod-borne vector, the malaria gets transmitted one person to another person. Animal reservoirs, in case of toxoplasma is also, it gets propagated to one person to another person. This type of epidemic, which are going from person to person, are through a vehicle in between, like arthropod acts as a vehicle for transmission of the disease from one person to person. It is also propagated. Sometimes the reservoir have the disease. Epidemic usually shows a gradual rise, tails off over a much longer period of time. It continues till all susceptible individuals are depleted. So during COVID, you can take the example. It started, epidemic started, became a pandemic, then it goes on depleting and depleting. Periodic fluctuation. There may be seasonal trend. It is characteristics of many communicable diseases. Measles, it is mostly seen in early spring. The upper respiratory tract infection shows their more occurrence during winter season. That is seasonal trend. Gastrointestinal infections, the flies gets multiplied in summer season, so they get, so most of the cases occur in the summer season. Non-infectious disease like sunstroke, hay fever, snake bite also exhibit some sort of seasonal variations. Cyclical trends. Some diseases occur in cycles over short periods of time. In cyclically, the diseases gets transmitted, means over a period of time. In cycles, it is called cyclical trend. In cycles, the diseases, some infectious diseases like measles in pre-vaccination era, major peaks appear every 2 to 3 years in measles, like infectious diseases. In periods, some years they will take. Measles again it will come before vaccination. Rubella also before vaccination. Every 6-9 years it will be calm, again it will rise. 6-9 years calm, again it will rise. This type of trend is called cyclical trend. We can see in USA the automobile accidents is more frequent during Sundays, that is weekends. That is also a some period in cycle it will come. Previous is the seasonal. The season affects this. Here cyclical, some period of time it will take. There are there are long-term or secular trend. Secular trend implies a consistent tendency to change in a particular direction or a definite movement in one direction over a long period of time. Means definitely, consistently, the graph is moving in certain direction. Over prolonged period, 40, 50 years, like that, it takes to show its trend, gradually increase, otherwise gradually going. Classical example is coronary heart disease, lung cancer, diabetes. Constantly, it will show an upward trend. In developed countries, during 50 years, it will show a declining trend of infectious diseases like tuberculosis, typhoid fever, diphtheria. Place distribution. Place distribution studies will be give differences in disease pattern in between countries and within the countries. Geographical patterns provides important clues about the causes of the disease. When you observe the disease, you will know in which part of the country where the diseases are more, which part of the country which diseases are less. Like that, we can have a picture by the geographical distribution. There may be the geography varies. The variations may be international variations between the nation, one country and another country. National variations within the country, there may be variations. Within the country, within the area, there may be rural-urban differences. There may be local differences between the outside city, inside the city. So variations help us to demarcate the affected area for providing appropriate healthcare services. These are affected, so you concentrate on these people. International variations. International comparisons examine the mortality and morbidity in relationship to socioeconomic factors, dietary differences, cultural and behavior differences. So there are variations at international level. They may be in case of mortality or morbidity data. We take example of stomach cancer is very common in Japan, but unusual in US. More cancer cases, stomach cancer, Japan than in US. Means one country is having more, but the other country is not having when you compare. Cancer of oral cavity and uterine cervix common in India compared to industrial countries, because oral cavity chewing of tobacco more common in India, and tobacco smoking also more in India, and the hygiene practices during menstruation among the women, getting vaccinated by human papilloma virus, and following good hygienic practices are more common, more well in the developed countries than in India. So both the cancers are more in India when compared to developed or industrialized countries. There may be variations within the countries. Within the country, like in India, you take fluorosis prevalent in Nalgonda and Prakasam districts of Andhra Pradesh. Compared to other areas, the fluorosis more common in those areas. Endemic goiter in hilly areas. Now it is decreased due to iodized salt intake in these hilly areas. So there are variations, national variations. There may be rural urban variations. Maybe differences in population density, social class, level of sanitation, education, environmental factors, deficiency, and medical care services. Who are living in rural area may not spend much money. Urban area, they'll spend a lot of money and that get rid of the diseases. The people, so there are differences, urban and rural differences. Level of sanitation, you can see everybody in urban area will have sanitary latrine. In rural area, there are no much sanitary latrines. They are more prone for infection of hookworm diseases. Local diseases, inner and outer city variations in disease frequency are studied by spot map. There is clustering of cases is suggested common risk factors shared by all. Cholera epidemic in Golden Square, that is Golden Square, Broad Street in London, you can see cholera epidemic. So locally also you can see the differences. You can see the spot map here. More, this is the Golden Square, means this is the Golden Square district, entire district. Here you can see at periphery there are less number of cases, where in Broad Street there are lot of cases in Broad Street, London, because of this pump which is having more contaminated water than the other pumps. So more cases and more deaths in Broad Street, London. Migration studies carried out in 2 ways: comparison of the disease and death rates for migrants with those of their kin who stayed at home. So we are comparing the disease and death rates of the migrants with those of their kin, means relatives or close relatives, blood relatives, are compared with who are migrated to other countries. Men of Japanese ancestors living in US experience higher rate of coronary heart disease than to Japanese in Japan. So native Japan compared with ancestors in Japan. Sorry, the Japanese who are migrated are compared with local Japanese people. The migrated people have experienced more coronary heart disease. Comparison of migrants with local population of the host country. After migration, Japanese in USA higher colon cancer rate as Native Americans in USA. So before migration, the Japanese are having less colon cancer. After migration, just like Americans, these Japanese are also having more colon cancer. Means the local geography or the environmental factors made them susceptible for colon cancer. Person distribution. The disease further categorized by defining the person who developed the disease by age, sex, occupation, marital status, habit, social status, and other factors. Based on the person we are defining the disease. Suppose you take example of age. Age is strongly related to disease than any other single factor. Certain diseases more common in certain age group, like atherosclerosis, more common in the old age. So age, person distribution, age, In this, which atherosclerosis in old age. Old age people are more at risk of having atherosclerosis. You can see bimodal distribution in the age group. Suppose we take example of Hodgkin's disease. Here the Hodgkin disease has peaked in the age group 20 to 30 age group. Again, it decreased in the middle age group. Again, it has increased between 70 and 80 years old. So this type of distribution is called bimodality of distribution. Marital status. Marital status can be a risk factor for some disease. The observation that cervical cancer is rare in men lead to hypothesis regarding marital status and cancer cervix. The cervix is affected with cancer, mostly sexually transmitted diseases. As nuns may have less amount of sexual activity, they may not be affected with cervical cancer. Occupation. For instance, while workers in coal mines are likely to suffer from silicosis, the coal workers mostly will get silicosis. They may suffer with silicosis. The upper socioeconomic status have higher expectancy, life expectancy, and better health and nutrition status than though in lower class. The upper class people will have longer life expectancy because of their health is good, their nutrition status is good. They can offer for good medical healthcare services. When you come to behavior, human behavior is increasingly looked upon as a risk factor in modern days. Diseases like coronary heart disease, cancer, obesity, accident. The person who eats a lot of junk foods generally becomes obese and he is more risk of cardiovascular diseases. So lifestyle, the lifestyle of behavior of the people influence the disease process. Stress lead to susceptibility or exacerbation of a lot of diseases. If you take example of tuberculosis, more the stress, the latent tuberculosis avoids and becomes TB disease. Migration, leprosy, because of movement of people from rural to urban area, leprosy also spread to the urban area. We are measuring the disease in terms of mortality, morbidity, disability. Mortality is straightforward. When you see the morbidity, means the suffering like that, you can take incidence, that is the new cases, prevalence of the old case. Incidence cases you can study to longitudinal study. You can get again the incidence cases from cohort studies also tells about incidence. Prevalence you will get from the cross-sectional study, well, a snapshot of the photograph or the gives the both the exposure and the disease outcome at the same time. Cross-section study, also known as prevalence study, is based on single examination of cross-sections of a population at one point of time. This is projected on whole population. So one time you are seeing the whole population and a certain a group of people, and you are projecting generalizing that sample to the all the people. These are more good for chronic diseases than a short-lived acute diseases. So chronic diseases we have to concentrate. Longitudinal study, to study the natural history of disease and its outcome, to identify the risk factor, to find out the incidence rates. Also this for longitudinal study are important. Observations are repeated in the same population over a prolonged period of time by means of follow-up examination. As we are following the, you can repeatedly, you are seeing the same disease process repeatedly you are seeing. So this is the type of is called longitudinal study. Comparing with the known indices, the essence of epidemiology is to make comparison and ask questions. Make comparison so that you will understand. Ask some questions about it. By making comparisons between different population and subgroup of same population, it is possible to arrive at clue to disease etiology. A clue may be there. You can identify some factors, risk factors. A clue you can get this may be affecting. So you can identify that by asking questions and making comparisons. Finally, you will formulate an hypothesis. The hypothesis should specify the following: the population, the characteristics of person to whom the hypothesis applied, the specific cause being considered, the expected outcome of the disease, the dose response relationship, the amount of cause needed to lead to a stated incidence of the effect. I will explain this, how much the dose. Time response relationship, the time period that will elapse between exposure to the disease and observe of the effect. This also I will explain. Suppose you are formulating a hypothesis. So the dose response and the time you have taken. The smoking of 30 to 40 cigarettes per day causes lung cancer in 10% of smokers after 20 years of exposure. Suppose a person is taking 30 to 40 cigarettes per day. Because of this is the dose. This much dose is causing 10% of the may cause lung cancer in 10% of the smokers after 20 years of exposure. That is about time. So he identified the cause, that is cigarette smoking. He mentioned the outcome, that is lung cancer. He told that 20 years of exposure, that is the time. So like that, we can formulate a hypothesis, identify the factor, but we are not testing the hypothesis. We are formulated the hypothesis and identified the, in this, we identified the risk factor for the disease. Thank you, everyone. This ends descriptive epidemiology, highly useful for the MBBS students.